Hi everyone. In this video, we're going to learn how to solve linear equations simultaneously, where the linear equation involves three unknowns, which I got a four example here, A, B, C, and D. Let's look at the first example, see how do I solve for the X, Y, and Z. In this example, I'm going to eliminate the variable Z first. So I will form the two equations involving the two unknowns, that is the X and Y. Then I will solve for the x and y first. After that, I will substitute the value, the solution of the x and y, back into the one of the equation here in order to get the z. So let's start. I got a three equation. Let's name it as equation 1, 2, and 3. If I take the 1 minus 2, look at the coefficient of the z for the equation 1 and 2. For the equation 1, I have the coefficient of the z positive 1, and the equation 2 having the coefficient of the z negative 1. If I take the 1 plus 2, 1 plus 2, then I will have a z plus negative z, then the z will be 0. All right, you can use this method to eliminate the unknown z first. So taking the 1 plus 2, I have 2x plus x, I got 3x. And the 4x plus negative y, you have a 3y. Where the z plus negative z, you get 0. 7 plus 2, you have a 9. So in this equation we can see that both of the left hand side and right hand side both can be divided by 3. So I will try to simplify it. And I have x plus y equals to 3. I will name this as equation 4. Then after that, I need one more equation which involving the unknown x and y only to solve for the x and y. So how can I do that? I'm going to take the second equation, multiply by 2. When you multiply the second equation by 2, the coefficient of the negative z will become negative 2. So negative 2z and the positive 2z, when I add them at the equation 2 and the equation 3 up, then the z again will be eliminated. So let's see how I do it. 2 multiplied by second equation multiplied by 2, I will have a 2x minus 2y minus 2z equals to 4. All right, every single term we need to multiply by 2. So I have this. After I have this, I name this as equation 5. And bring down the equation 3. I got a negative 5y plus 2z equals to negative 7. I will name this. This is actually we just now already named it as equation 3. So now I'm taking the equation 5. Plus equation 2, meaning that, equation 3, equation 5 plus equation 3, you can see that negative 2z plus 2z will be equals to 0. So in this way, in this case, the z will be eliminated. So let's consider other term. 2x plus 0, I got 2x. Negative 2y plus negative 5y, I got negative 7y. 2z, negative 2z plus 2z will be equals to 0 and equals to 4 plus negative 7, you got a negative 3. After I have done this, now I'm going to substitute the x, okay? You can actually make the equation 4, okay? Make the x into the subject, meaning that put the x as a subject. In terms of y term, you have x equals to 3 minus y. You name this as equation 4. Then my step will say is that 4, substitute 4 into the equation. This is 6. I name this as equation 6. So put the 4, substitute the equation 4 into the equation 6. Means that I'm going to substitute the x as a 3 minus y. So you will have 2 multiplied by 3 minus y minus 7y equals to negative 3. All right, so now this equation just contain the unknown y, meaning that you can solve for the y later on. Expand this, you get a 6 minus 2y minus 7y equals to negative 3. And simplify further, you got a negative 9y equals to negative 3 minus 6, that is negative 9. And the y, you have a 1. All right, we have successfully got the solve for the y. So now I'm going to substitute the y equals to 1. Substitute y equals to 1 into the equation 4. Okay, equation 4 that we have just now, that is x equals to 3 minus y. X equals to 3 minus y, where the y now you can replace it by the 1, then we can say that the x is equals to 2. So now you have done, you have found the solution for the x and the y. Now it's just we need to substitute the two value either in the equation 1 or equation 2 or equation 3. So I will choose for the I choose equation 2 to be substituted in. Equation 2, giving the equation 2 as a x minus y minus z equals to 2. This is your equation 2. So now I will substitute x equals to 2 and y equals to 1 into the equation 2. Okay, so what happened? You can see x will be replaced by 2, y will be replaced by 1, and the z will be still remain as z equals to 2. So z will be equals to 1, 2 minus 1 is 1, 1 minus 2, that will be negative 1. All right, so you got z equals to negative 1. Okay, so finally you will conclude that x equals to 2, y equals to 1, and the z equals to negative 1. So if you would like to check your answer, if to see if you got the correct answer, you can substitute these three values into the equation, into the system of linear equation above. Okay, let's see, 2, 1, negative 1. If I put the 2, 1, negative 1, 2, 1, negative 1, meaning that I will substitute the x as 2, y as a 1, z as negative 1. See if you will get 7. Okay, if you get the 7, the value of 7, just like the right hand side. So just expand it. 2 multiplied by 2, 4. 4 plus 4, 8. 8 minus 1, yes, is equals to 7. All right, means that our solution is satisfying the equation 1. Try for the equation 2. Okay, we substitute the 2 into x, 1 into the y, and the z as a negative 1. So you got 2. 2 minus 1, that is 1. 1 plus 1, that is 2. Yes, it's equals to the right hand side. So you can continue checking by substituting those values into the equation 3. I believe that this 3 value will satisfy 3 equations. All right, so we say that this is a solutions of our linear equation. Let's consider my second example. Okay, so here I'm going to eliminate the x. Since the coefficient of the x is easy for me to eliminate, I just name this as equation 1, 2, and 3. If I take the 1 plus 2, the x will be eliminated. Negative 2x plus 2x will be 0. Negative 3y plus 2y will be negative y. And 4z plus negative 3z will be positive z, equals to 1 plus 2, that will be 3. All right, let's check back. Okay, then after that, you will have you can have a z as a subject. Bringing the negative y to the right, you have a 3 plus y, and I name this as a equation 4. And now I'm going to eliminate the x again, okay, produce another equation which containing only y and z. So how can I do that? I'm going to take the equation 3 multiply by 2. All right, taking the equation 3 multiply by 2, I will have 2x plus 4y minus 4z equals to negative 3 multiplied by 2, that will be negative 6. Then taking this equation, name it as equation 5. You can actually taking the equation 5 minus equation 2, or taking the equation 5 plus equation 1, you also will able to eliminate the x, the unknown x. All right, so either one. you're taking, so in this case, in my case, I will use the equation 5 minus equation 2. Okay, taking the equation 5 that I produce here minus equation 2, I got 0 for the x term. And then 4y minus 2y, you got 2y. Negative 4z minus negative 3z, then you will get plus 3z. That will be negative z. Okay, equals to negative 6 minus 2, that will be negative 8. All right, then I will name this as equation 6. All right, after that, you are going to focus on the equation 4 and 6. We are going to solve these two equations simultaneously. All right, substitute equation 4 into the equation 6. Okay, substitute the z, meaning that the z over here will be replaced by the 3 plus y. So you will have a 2y minus z. Z is going to be replaced by the 3 plus y. And this is equals to negative 8. Okay, so simplify further. You have 2y minus y, that is y. And here you have negative 3, bring over. You got a negative 8 plus 3, that will be negative 5. Okay, so you already solved for the y. Now substitute this y equals to negative 5 into the equation 4 in order to get the value of z. So z given in the equation 4 is 3 plus y, meaning that z is 3 plus y. Our y will be replaced by negative 5. So z will be equals to negative 2. Okay, once you have your y and z, I'm going to substitute y equals to negative 5, z equals to negative 2, either in the equation 1 or 2 or equation 3, up to you. Okay, as long as the substitute into the equation which involving the unknown x. So I choose to substitute into the equation 3. Equation 3 given as a 2x, x plus 2y minus 2z equals to negative 3. All right, let me check. Yeah. Okay, so I'm going to put the y as a negative 5 and the z as a negative 2. This is equals to negative 3. So trying to simplify it, you will have negative 10 minus 4 equals to negative 3. Finally, you have negative 14. So negative 3 plus 14, that will be x equals to 11. Now we try to substitute the three values that we got it just now into the equation so that we can know our answer found, is it correctly fixed, satisfied the equation. Okay, so substitute x equals to 11, negative 5, negative 2. 11, negative 5, negative 2. Okay, let me check. 11, negative 5, negative 2. So this is 11. 11 multiplied by negative 2, negative 22, plus 15, and minus 8. You get so when you after I calculate, okay, I got my value at the left hand side is not equal to the right hand side, meaning that something wrong with our answer. So here after I check, I've done a mistake over here because the sign negative 2 multiplied by negative 2, that will be positive 4. All right, so this will be negative 6. Bring over to the right hand side. You will have a positive 6. So finally, the answer x is actually has to be 3. Okay, so this one, we do some correction. Now I'm going to substitute this as a 3. So let's see, is it satisfied the equation 1? Negative 2 multiplied by 3, I got negative 6 plus 15. Negative 6 plus 15. And then minus 8. I got 1, which is equals to the value of the right hand side. All right, then you can check for the second equation. All right, I believe that you will get the value at the left hand side, produce a value of 2, which is equal to right hand side. And you can continue by checking your answer by substituting into the equation 3. Let's consider the example 3. In this example, I'm going to use substitution method, which because what I see in the equation 3, I name this as equation 1, 2, 3. Equation 3 having only two unknowns. So it's easy for me to put the x1 as a subject in terms of x3. Then I'll name this as equation 4. I'm going to put the equation 4 into the equation 2 and then put into the equation 2 and 1. All right. Then from there, I will produce two equations which containing only the x2 and x3. All right. So from there, I can solve for the x2 and x3 very easy. Now, so this method is called substitution method. Now, I will put the 4 into the equation 1. See what happened? You got the 3. x1, this x1 is going to be replaced by 5 minus x3 plus x2 plus 2x3. All right, then we expand and simplify. So after simplify, I got my x2 minus x3 equals to negative 4. And you may always write the x2 in terms of x3. Okay. And later on, this is very useful when we're going to solve for the x3. Okay, so I'll name this as the equation 5. After that, the same steps for as a step just now. I'm going to substitute the equation 4 into the equation 2. Okay, into the equation 2. So what I have now is 3, 5 minus x3, which the x1 replaced by 5 minus x3, plus 2x2 plus 2x3. This is equals to 10. Then simplify and you form the equation. Forming the equation consists of only x2 and x3. After I simplify, I got 2x2 minus x3 equals to negative 5. And we name as the equation 6. All right. So now I'm going to solve for the equation 5 and 6 simultaneously, where replacing or putting this x2 as a negative 4 plus x3 into the x2 here. So my steps will be, I will write equation 5, put the equation 5 into the equation 6. Then you will have a 2, x2 is going to replace by negative 4 plus x3 minus x3 equals to negative 5. Simplify. You will have this after you have expanded. Then you have x3 equals to 3. All right, so we already got the x3. So how can I get the next unknown? I'm going to find x2 now by substituting x3 equals to 3 into the equation 5. Okay, so you will have your x2 equals to, putting the x3 as a 3, you have your x2 equals to negative 1. After you have x2 and x3, you can substitute both value. That is substituting x2 as negative 1, x3 equals to 3 into either equation 1 or equation 2 or equation 3, or it might be equation 4 because I'm going to find x1. So x1 equals to 5 minus x3. x1 5 minus x3. This is given by the equation 4. All right. So I'm going to put the x3 into the equation 4, which x1 equals to 5 minus x3, which is equals to 3. Then I got my x1 equals to 2. So finally, we can conclude that our solution is x1 equals to 2, x2 equals to negative 1, and x3 equals to 3. Again, you can always check the answer by putting those values into the equation. When you substitute 2 inside, you got 6. 6 minus 1, that is 5. 5 plus 6, that will be equals to 11. Yes, it's equals to the value of the right hand side. You can always check by substituting those values into the second equation and the third equation. Okay, see if the value of the left hand side is equals to the right hand side. All right. So this is the last example that I have. In this question, I'm going to eliminate x1 because taking the equation 1 minus equation 2, your x1 will be eliminated. And I name this as equation 3. Okay, so taking the 1 minus 2, you will have x1 gone, and negative x2 minus 3x2, you got negative x2, and 2x3 minus negative 3x3, you will have positive 5x3. And the constant part is 3 minus negative 5, you have 8. I'll name this as equation 4. And later on, I'm going to take the equation 2, multiply by 2 so that the coefficient of the x1 become 2x1 like that. So later on, the 2x1 here can be eliminated with the 2x1 in the equation 3. So let's see how we got what we got when it multiplied by 2. So I have 6x2 minus 6x3 equals to negative 10, and I name this as the equation 5. After that, taking the equation 3 minus equation 5, which 2x1 minus 2x1 will be eliminated. And 3x2 minus 6x2, you got negative 3x, negative 3x2. Okay, 3x2 minus 6x2, you got negative 3x2. x3 minus negative 6x3, you have 7, positive 7x3, which is constant, is equals to 9 minus negative 10. That will be positive 19. Okay, then I'll name this as equation 6. Okay, so now I want to eliminate the x2 here by solving the equation 4 and 6 simultaneously. So before that, I'm going to take this 4 multiplied by 3, and then 6 multiplied by 4, so that I have my coefficient for x2 become 12. Okay, both become negative 12. So 4 multiplied by 3, you got a negative 12 x2 plus 15 x3 equals to 24. I name this as equation 7. And when your equation 6 multiplied by 4, you got negative 12 x2 plus 28 x3. Okay, after that, 19 multiplied by 4, we name this as the equation 8. So now you can see that the both equation having the coefficient of x2 is negative 12. So to eliminate the x2, we can take the equation of 7 minus equation 8. All right, when you have a negative 12x2 minus negative 12x2, you got 0. Okay, and then 15x3 minus 28x, you have a negative 13x3. At the right hand side, you have a negative 52. Taking the negative 52 divided by negative 13, you have positive 4. Okay, so once you get the x3, you can either substitute the x3 equals to 4 into the equation, maybe equation 6, all right? Okay, or equation, yeah, I'm going to substitute into the equation 6. So I will have my negative 3 x2 plus 7 x3. x3 is going to be replaced by 4 equals to 19. Okay, so see what you got for your x2. Simplify, you will have x2 equals to 3. Okay, you will get x2 equals to 3. So after that, you're going to solve for the x1 once you have the x2 and x3. So now we are going to substitute x2 equals to 3 and the x3 equals to 4 into where? Either equation 1, 2, or 3. I choose to substitute into equation 1. This is the equation 1. Now I'm going to put the 3 as the x2 and the x3 as 4. Yeah? Then solve for the x1. That x1 equals to -2. So we conclude that overall we have x1 equals to -2, x2 equals to 3, and x3 equals to 4. This is the solution of the system of linear equation. All right, thank you for watching.